So today we'll look at topic 8-6 in the trigonometry unit of geometry. Start out, and if you don't have a stamp yet for yesterday's homework, we'll take care of that now. Yesterday in 8-5, we worked on writing trig ratios from a given angle. Today we're going to look at finding the missing sides using trig. And so we start out with the bell work. Look on page 17, pause the video, and work on the bell work problem. Okay, one thing that you had in your book from yesterday, the little code word for the trig functions is SOHCAHTOA. SOHCAHTOA. So the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So you've got to keep that in mind as you're looking through all these things. No matter what, this side here is going to be the hypotenuse. So the first one says the sine of A. Sine is opposite over adjacent. So if I look at angle A, the opposite side is 15. The hypotenuse is 17. Number 2 says the cosine of A. Cosine is adjacent over hypotenuse. So still looking at angle A, the adjacent is 8. The hypotenuse is 17. Now, number 3, we get to the tangent of A, which is opposite over adjacent. So the opposite from A is 15. The adjacent to A is 8. Now we'll do the same kind of idea for angle B. So when I look at angle B, this side over here is the opposite, and this side next to it is the adjacent side. The hypotenuse stays the same the whole time. So the sine of B is opposite over hypotenuse. That's 8 over 15. Not 15, 17. The cosine of B is adjacent over hypotenuse, which is 15 over 17. And then the tangent of B is opposite over adjacent. And so that's 8 over 15. And that's a recap of what we looked at yesterday with writing the ratios in a trig function. So now flipping back to page 6, looking at the notes for topic 8-6. It says here at the top you need a calculator. So if you don't have a calculator yet, pause the video, grab a calculator. And the first thing it says is to make sure the calculator is in degree mode. So if you turn on your calculator, probably looks like this, may have some writing on there, whatever. So there's your calculator. Press mode. That's right up here. I press mode and it looks like this, and maybe you have different things highlighted. But this third one needs to have the word degree highlighted. So if it's radians that are highlighted, if it looks like that, go over, click till you get to the degree, press enter, and that'll toggle degrees on because you want your calculator in degree mode. Now to get out of this, press second and quit. That's second mode, and you're back to this home screen. So we want to use the calculator to find these values right here, and then we'll connect the dots with what we did yesterday. So the sine of 12, to get that, you press the sine button, and then 12. And it's as straightforward as that. The sine of 12 is 0.2079. We'll write a bunch of decimals on these. It's okay to write 4 even. We don't need to round these off too much. The next one says the cosine of a 24-degree angle. Cosine of a 24-degree angle is 0.9135. And finally, the tangent of a 54-degree angle is 1.3764. So that's all you have to do to find those particular values. Now what we want to do is use the trig functions to find the missing sides when the Pythagorean theorem doesn't work. So in both cases, I need a right triangle. But if I only know one side, I can't get to the Pythagorean theorem. I could perhaps figure it out by knowing what these angles are. And so that's what we're looking at here. Here's SOHCAHTOA, and it's just a reminder of what those things look like. That letter right there is the Greek theta, and so that's their reference on this particular one. It's starting here. That would be the opposite side. The adjacent's the one next to it. The hypotenuse is always opposite the right angle. No matter what, for that triangle that's drawn right there, this will be the hypotenuse. Even if I change to look at a different angle, the hypotenuse is still that line in red right there. So we want to find the missing sides here. And it says, first of all, we want to label the sides, hypotenuse, opposite, or adjacent. Use the correct trig function, and then solve it. So, for example, on this first one, if I'm looking at that 42-degree angle, the x is going to be the opposite side. The 25 is going to be the hypotenuse, or the h, and the adjacent side is going to be this side over here. So the two things that I have are the opposite and the hypotenuse. Well, using my trig functions, that's the sine function. So looking at this, for example, the sine is the opposite over the hypotenuse. So that's what I've got going on for this problem. It's the sine. Or put a different way, the sine of 42, because the angle is 42, is the opposite, which is x, over the hypotenuse, which is 25. We would end up, to solve this, we would end up cross multiplying. So this is 1x equals 25 times the sine of 42. So I'm going to use my calculator right there to go 25 times the sine of 42. Now I want to be careful. It's not the sine of 42 times 25. It's just the sine of 42 times 25. And that works out to be 16.728. And I think as you start looking at these, if you will think about putting that number right there on that side, eventually you'll see numbers that make sense. So if that length right there was like 300, you definitely made a mistake because the hypotenuse has to be the longest side. If that number was like, I don't know, negative 0.4, you made a mistake. And so that kind of helps you get an idea if you're doing things properly. Let's look at the second one. Label the particular side. So here's my angle. This guy here is the hypotenuse. This is the opposite. And this is the adjacent. All in reference to that original angle. So the parts that I have are the opposite and the adjacent. From my notes back here, the opposite and adjacent, that's a tangent. So the tangent of theta is the opposite over the adjacent. Or, plugging in the numbers, the tangent of 75 is the opposite, which is 12, over the adjacent, which is x. Again, I'll cross multiply, so I get 12 equals x times the tangent of 75. Or if I divide both sides by the tangent of 75, I get 12 over the tangent of 75 equals x. So now I'm going to grab the calculator, and I'm going to say 12 divided by the tangent of 75. And I like to put the stuff on the bottom in parentheses. I just think that makes it a little neater. I could also just do it like this, the tangent of 75, and then say 12 divided by that answer, so second and the negative sign. That works out to be the same thing. You see it's 3.215. So x here is 3.215. Again, that number kind of makes sense right there. It's less than 12. It's not tiny, tiny or huge, huge. It's a reasonable number to put in that triangle. Number 3, same routine. This is the hypotenuse. Based on this angle, this is the opposite side. This is the adjacent side. So the parts I have are the adjacent and the hypotenuse. The adjacent and the hypotenuse, if you were looking at your little acronym, the adjacent and the hypotenuse go with the cosine. So the cosine of theta equals the adjacent over the hypotenuse. Or plugging in the numbers, the cosine of 36 equals the adjacent, 19, over the hypotenuse, x. And you might have noticed, since I'm cross multiplying, this thing that I have written right here is actually the same as this. Basically, these two things here just switch places, because you can see when you cross multiply, it works out to be the same way. Well, this way I've done it in red is a little nicer, because now this just says x equals 19 over the cosine of 36. I strongly recommend writing down the different steps as we go through it instead of trying to do a bunch of rearranging in your head, because that's when you end up with the wrong answer. So it's 19 divided by the cosine of 36. Do it on your own calculator. Don't just watch me do it. Make sure that you can click the right buttons and do the right steps while we're doing them as notes so that you can do it on your own. So x here is 23.485. And finally, let's look at number 4. So I'll give you a second. Label the parts. Figure out which trigonometric function you're going to use. In this case, it's the tangent, because I have the adjacent and the opposite are the sides that I have. So it's the tangent of 53 that equals the opposite over the adjacent, or equals x over 7. When I cross multiply, I get 1x equals 7 times tangent of 53. 7 times tangent of 53. 9.289. So I want to show you real quick a common mistake on these problems. If you started out and you did not have your calculator in degree mode, you had it in radian mode. Don't go back and do this. Just watch for a second. I'm going to leave it in radian mode now, and I'm going to do the same problem I just did. Same problem. Here's the answer it gives me, -3. Now don't just blindly write down -3. How could that side be -3? It couldn't. Obviously we've done something wrong. And in this case, the easy common mistake that students make is they forget to put their calculator in degree mode, and it's working stuff out differently. Since this 53 is in degrees, your calculator over here needs to be in degree mode. So as long as you've left it like that, or you check and make sure that it's in degree mode, now when I do that function, I get the answer that I'm looking for. So at this point, you've got some problems to practice on your own. Go through those things. Use your notebook. Use your little SOHCAHTOA acronym. Show the steps, and you'll be fine.